All right, let's talk about that little bit of magic that happens in the split second after you hit the power button on your computer. We're going to pull back the curtain on how your machine actually figures out what it's made of. You know that feeling, right? You slot in a brand new graphics card, you boot up, and it just works. Well, that's not magic. It's actually this really clever detective process called PCIe enumeration, and it happens every single time you turn on your machine. So let's dive in.
Think about it. When you first hit that power button, your computer is basically just a box of parts that don't know each other. The processor, the memory, the new SSD, they're all silent. So the very first job for the system's firmware, the BIOS or UEFI, is to create a map, to figure out what's plugged in and how to talk to it.
And that process has a name: enumeration. It's the foundational step. You can think of it like a roll call for all your hardware. It's how your computer builds a complete, detailed map of itself from scratch, every single time it boots.
So, where does this whole investigation kick off? It starts right at the heart of your system, with a component called the root complex. This is basically the main hub that connects your CPU and memory to everything else, and from there, the search begins.
The system doesn't just scan randomly. It's very methodical. It uses what's called a depth-first search. Imagine exploring a maze. You go all the way down one hallway, checking every door, before you ever think about turning back to check another path. It's a systematic way to make sure nothing gets missed. Now, to keep track of everything, you can't just wander around aimlessly, right? The system uses this awesome coordinate system called BDF for Bus Device Function. It's like a unique street address for every single potential slot in your computer. This lets the firmware ping any exact location and ask, "Hey, is anybody home?" And this slide right here, this is the entire playbook. This is the 5-step process our little hardware detective follows every single time. First, you detect if anything's there. Then you identify what it is. You organize the pathways, allocate the resources it needs, and finally, you flip the switch to turn it on for the operating system.
So how does it actually ask, is anyone there, at each BDF address? It sends out these special little pings called configuration transactions. It uses a type 0 transaction to talk directly to an endpoint, the final destination like your graphics card, and it uses a type 1 transaction for bridges, which are like the intersections that connect one bus to another.
Okay, so a device responds to one of these pings. What's next? Well, the system basically asks to see some ID. It's time to check the device's built-in passport.
And this passport isn't just a simple piece of paper. Every single PCIe device has this block of data baked right in, called its configuration space. It holds everything the system needs to know. And while the standard header is 256 bytes, the full space can actually extend up to 4 kilobytes to list all of a device's advanced features and capabilities.
Inside that space, you find these golden nuggets of information. The vendor ID tells you who made it, like 10DE for NVIDIA. The device ID tells you exactly what product it is, like 2204 for an RTX 3080. It's a perfect identification system. And if the system probes a BDF address and just reads back a string of ones, it knows that slot is empty and just moves on to the next one.
I love this quote because it just nails it. The config space isn't just an ID card. It's the device's passport, sure, but it's also a full user manual listing every capability it has. And it even provides all the switches and dials needed to control those functions.
Okay, passport checked. We know what the device is, but it can't do anything yet. It needs a place to live, an address in the system's memory map so the CPU can actually find it and use it.
And this is where something called base address registers, or bars, come into play. You can think of these as the device's official request form. It uses up to 6 of these bars to raise its hand and tell the system, hey, I'm going to need this much memory space to do my job.
What happens next is this really clever, super fast negotiation. It's like a little handshake. First, the firmware writes all ones to the bar, which is like asking, so how much space are you going to need? The device then writes back a value that indicates the exact size it requires. The firmware then finds an open block of memory that's big enough and says, okay, here's your new address. Go set up shop. And once that address is written into the bar, that's the game changer. That address becomes the device's base for memory mapped I/O, or MMIO. This is so crucial because it means the CPU can now talk to the device's registers just by reading from or writing to that specific chunk of memory, almost as if it were just another part of the system RAM.
And with that final step, the case is pretty much solved. All the devices have been found, they've shown their passports, they've been given a home in memory. Our hardware detectives' work is done.
So let's just recap what we've got now. The system has a complete working map of everything that's plugged in. Every single device has its unique BDF address, a clear identity, and all the memory space it asked for. Now, and only now, can the operating system take over and start loading the right drivers to bring it all to life.
It's pretty amazing when you stop and think about it. This whole discovery process, this digital detective work that happens in the blink of an eye when you boot up, is what makes the plug-and-play world we live in possible. It's truly the silent, unsung hero of your PC.
But of course, getting the hardware all set up is only half the battle. How the operating system and drivers take that map and actually make things happen, well, that's a story for another time. Thanks for digging into the details with me on this explainer.